Hello. All right. So today we're going to talk about what to test and where to test it. This is going to cover a fair bit of material. It's also going to be particular to Rails, which we're working in. Some of it is applicable to the general world of testing. All right. So let's get started. There's a book that I have in some of the recommended reading. Rails 5 Test Prescriptions by Noel Rapin. He's got some good advice in there. And one of the pieces of advice that he has that I thought was good to share is that he has this idea for what he basically describes what is his test-driven development, as he calls it, his meta process. So we know that when we do test-driven development, where the idea is we're going to start with a test, then we're going to see that it fails, and then we're going to continue on, and we're going to write a little bit of code to get that test to pass, consider about refactoring it, and so forth, and repeat till death do us part almost, or something. Anyway. But where should you really start with your tests? And so this is where he has this notion, and it's a pretty good one, I actually think, which is he proceeds through these steps basically. He likes to start with testing what he calls the initial state. And testing the initial state, this is really what you're going to do is, this is all about, I would say, if you're talking about unit tests, this is arrange and assert. No real sort of act in place. And so you're testing an object, and everything is it's all filled with objects. Your systems, the notion is you got an object, you want to be trying to test it. The first thing you have to do is you have to create one of these objects. And so you have to call initialize on it. You have to call the constructor, whatever you want. Well, when you do that, what's the initial state it's in? And the idea is basically, he starts off with a really easy test to I've made an object. Now, when I make an object, it should have the following properties to it that I can see and test, which actually makes a lot of sense. It's just like, when I set up my object, does it get set up the way I expect it to be set up? And so that's where he starts his test-driven development there. And that's that's like a platform. Like, if that's wrong, how are any of the other tests going to work correctly for you? Then he moves on, and then he picks basically the simplest happy path. So again, the happy paths are when we are doing some testing and we expect if I get this data, it'll all work nicely, and I should get this. It should behave like this. It's what we usually, unfortunately, it's where a lot of testing stops. But he starts there, because if that doesn't work, why would any of the more complex things actually work? Then he goes and he moves on to, as he says, all right, I'm going to go through all the other happy paths that I can think about now. All right, so he writes tests for those. Great. Then he's basically, we've got the initial state, we've done all these happy paths. It seems to be working pretty good. Now's where he's ready to focus in on testing all the errors and the sad paths and the edge cases. All right, and so now's the time when he's like, well, if you think about a method, it might very well be, well, yeah, what happens when I pass in values that should throw error conditions? All right, he's going to test those. Same thing, like if you're testing a form on the web page. Now, this is the ones where it's like, what happens when we don't fill in something? We should get an error message. Or on a model, it's let's check not the items that would pass validations, but let's check the items that would fail validations. And the same thing with the edge cases. These are at the boundaries of things where things start to fail. Let's start testing it out. And so that's his meta process. And if you're looking for sort of an overall guidance to where to get going with test-driven development, I think this is a good way to proceed. Now, a lot of what we're going to talk about now is about Sandy Metz's chapter 9 in her book on object-oriented programming. And her chapter 9 is entitled Designing Cost-Effective Tests. And what she means by this is, and this is a phenomena that she and other people report, is that sometimes people go from a world of not really doing any tests, that's bad, to they catch the test-driven development bug and everything looks like it needs to be tested now. And before they know it, the people report, all I'm doing is testing. I'm not writing any new code. Oh my gosh, I'm drowning in my tests and tests and tests. And this is sort of a message that she has here, which is, well, let me help you figure out what you should really be testing so that you don't lose control over this. And everything in Ruby is object-oriented. And so you could think about given a class or given an object. So given a class, what should we be testing? All right. And our message, in the book and in the lecture that she gives, she talks about it as a space capsule. And so if that works for you, great. To me, I think it's better just to understand it with the traditional terminology that we treat it as a black box. The idea being that, and maybe it actually, we should be calling it, we treat it as a white box or something, but the reality is we don't care how the internals are implemented, okay? So, and this is a general principle that we have throughout all of our software, is that we like to hide and we want to hide the implementation. And we do not want to be dependent upon it when we write our software. So we've got a class, and if we depend upon the implementation, we can't change it without changing everything else in the system, because the rest of the system has become dependent upon how we implemented the internals of the class, and that's really bad. And so you know very well that we create nice public methods for our classes, and then we hide the internal data. And in Ruby, by default, the internal data is all private and is not accessible, which is a good default design setup by Ruby. And as well, we can make private methods that the class uses internally that no one else knows about, but we use them to help us implement all the public methods. Now, and so we know that this is a good design principle to sort of encapsulate all of that functionality, hide the implementation, okay? Think about testing. If you now, as a tester, write your tests dependent upon the internals, you sort of have violated it. Now all your tests are dependent upon that implementation. And if you wanted to change the implementation of the class, all of your tests have to change. I mean, the reality is testing is writing basically another large piece of software. You got the one piece of software that you're going to send to the client, and you have this other piece of software that you're basically writing for yourself, your internal usage, and it's testing this other piece of software. But they should not be super tightly coupled. The tests should not know about the internals. Otherwise, yes, I know a way to improve the software over here. Now it won't change any of the interface of that class, and it won't change any of the public methods or anything observable from the outside. I'll change the internals, but all my tests break. Well, the moment all those tests break, one, you have to write them again, but two, you also have lost the ability to do your regression testing. So regressions, remember, are when tests that we used to pass now start to fail. So if you have to write new tests, you're not really doing regression testing anymore. You're not finding the regressions. You're just having to create new you're wasting your time. It's a bad idea. Your tests should not be dependent upon the internal implementations of the classes. So you're going to treat it as a black box. So this really, what this leads us to is the first rule of Sandi Metz basically is don't test private methods. Okay, if you do this, you're going to entangle yourself, and you're going to be building too close to the implementation, and again, you won't really catch regressions this way when you try to change the code, because by default the tests will break. That's not telling you that there's actually a bug. It's just telling you you need new tests, and so unfortunately, then you won't really be detecting those important changes. I'm searching for a good pen here. I need to order some new ones. All right. So with this in mind, you have this notion that, so we're going to have some sort of class here. All right. And this class, or we could talk about it as an object, there are going to be incoming method calls on it. So, again, let's say we have a class that implements a binary search tree, So you might very well have a method that adds an element to that object, and it goes into the binary search tree. You could have a method that asks it, how many keys do you have in your binary search tree? You could have a method that calls upon it and it says, search for this key and return me the value. So there's all these sorts of methods that a class that was implementing a binary search tree could have on it. All right, so those are you've got an object and other objects are calling on it and either asking for data, sending it data, they're interacting with it. So you have these incoming calls. There's going to be a whole bunch of these, and they can come into the class. Now, likewise, it's possible to have the class have various outgoing method calls as well, because some classes need to use other classes to get their job done. This is what we've been talking about with our dependency injection. So, oh yeah, this class uses this class. Let's go ahead and inject it rather than just have it sit inside of there, all that sort of stuff. But it's certainly likely that classes will use other classes. You could envision that maybe instead of a binary search tree, we had implemented here a heap. And what we wanted to do is actually write a class that was a priority queue. So this is a queue. It's a queue where items have a value, such as we'd say a priority, and we always want to be able to find the highest priority item quickly. And so we're putting items in, and whenever we ask what's the highest priority item, we're able to pull it out. It's like, and it's queued up by highest priority. And to implement that, we'd likely use a generic implementation of a heap. And so that it's possible that a priority queue class could have inside of it and be using a heap class, which to the class that it's using, those are incoming messages. And so you have another, so or one class is outgoing and another class is incoming. This seems pretty clear and obvious, but let's not forget it. When we're calling other objects, from their perspective, those are incoming method calls. Again, Sandy Metz calls these messages. This is a very traditional object-oriented way of talking about message passaging between objects, but I cannot get beyond my upbringing in C++ and Java and C# where we have method calls. So we have incoming method calls, outgoing method calls. The outgoing method calls are incoming to another object. And so with that in mind, that we have to think about things are incoming and outgoing. What Sandy then tries to distinguish, and I think it's a very good thing, she admits that it's not a perfect way of understanding, sort of classifying methods, but it's a good way to, it's a good general classification. And she's got two types of methods. So one type is called a query method. Now, so a query method, so again, we have an object, we have a class, we're going to call this method on that object. And it has, when we call this, it has no visible side effects. In other words, it doesn't change anything about the object that we can tell. It might change something on the inside, again, from the black box perspective, but we don't know that. But from our perspective, nothing changes when, anything that we could probe or test on the outside by calling other methods about that object, there's no visible side effect. Okay. So from our notion, the method only can be seen to return a value. So we call the query method and it returns some value to us. And I would say, for example, let's say, we have again our, our binary search tree, and a method that would be a query method might very well be the count method. How many things do you have in you? Well, we expect that the tree will just go, I have 23 things in me. I'm empty, I have 0 things. We don't expect it to go change anything. Now, it's entirely possible that some of these methods might actually, that we don't think of changing anything. Internally, you could have a method that runs all sorts of code, records a value, then returns that value, and then on future calls, it says, ooh, has anything changed since the last time I've calculated this value? And the answer is no, and it just simply returns it. Now, internally, basically some state did change. We stored a value and we're checking has anything changed in the meantime, all that sort of stuff. But from the outside of the class, it's just, oh, what's your count? Or what's the other property of this? Just return it to me, give it to me. Do something and I just expect a return value from you. I don't expect anything else that I can tell from the outside of the class to actually have changed by me making this call. And so those are called query methods. All right. Then the other type are called command methods. And I do like this terminology. So this is let's query the object. It looks at something and it returns something to me. Okay. The command method is basically telling the object, go do something. Now, the nature of a command method is that it really, the reason you're giving it these commands is it produces some sort of visible side effect. Or visible side effects could be multiple, and let's just be honest, a command method can return a value. All right, well, it's an example. Well, let's imagine you had a stack. All right, well, stack, I hereby command you to pop the top of your stack and give it back to me. Well, so pop, we really do expect it to change the stack. And so what's a visible side effect of popping something off a stack? Well, its count should change. So the number of things in the stack should be decremented by 1. So that's an example of, we told you to do something. You could implement pop so it returns the value to it. Sometimes you implement pop so it doesn't, but you could certainly do that. So it could be returning the value. But we were telling the object to do something with the whole intent and purpose that it will change the object, and such that then we will be able to notice that there is some actual change to the system for us. And those are called command methods. Now, these are all public methods again. We're not talking about any of the private internal methods to the class. We're not talking about any of the private internal data. We're not going to try to test any of that. In other words, we wouldn't, with a stack, go, oh, I want to go look and check your internal data representation and see how you actually popped that off and make sure you did it right. No, we're interested in what can we observe from the outside of the class, and so one of the really key things would be we could check to see that the count is decremented by 1 if we pop something off. You could as well, if you wanted to, you could go one step further and you could push A onto the stack, push B onto the stack. You could pop B off, and then you could do a peek at the top of the stack to see that A was sitting there, because you would expect, if there was a peek method, to peek at the top of the stack. So you could do that. But some stack implementations don't have that. All you're allowed to do is, pop and push. And so, you'd have to pop again to check to see that you got A back. You could do that sort of thing. Absolutely. But that's the way the mentality is thinking. We're not even going to think about or try to envision, trying to test the internals of the method, just the externals of it. This is not to say, though, that you should not be looking at the code inside of a class. Oh, absolutely. You should be. It's not truly a black box, okay? So when you look at the code, you can see, oh, I see that. I wonder, there might be a bug there. Well, how can I test it through the calls to it, through these calls on the query methods and the command methods, to actually expose what I think will trigger a bug? Or you run a coverage report and you find out that there's a whole bunch of lines of code inside of a class that your tests aren't covering. Well, go look and see what that is. Why is that? What did you not understand about that class that your tests aren't actually touching those lines of code? All right. So I think the idea is you kind of, you can see inside the class, but you shouldn't be testing the internals, okay? So don't truly make it a black box, but test it like that. And I think, again, I forget, is that called a gray box? Is it called a white box? I forget. Let's not worry about that. Let's really just focus on how to get things done. All right, so then the big thing is Sandy Metz comes up with this really nice chart that tells us what should we be testing. So we have the call or this message. So what's the origin of this? So we have, as we talked about, we have incoming method calls. So these are coming into the object. We do have, we've talked about it, we have internal to the object itself. It calls itself inside itself. And we have outgoing calls. So where it's going to call a method either a query method or a command method on some other object. And so again, we have the two types. We have a query method and we have a command method. All right, with the query methods and command methods, now we've got this nice sort of grid, I suppose, table that we can fill out. All right. If we have an incoming message or incoming method call, and it's a query method that's being called, what do? Well, this is pretty easy. It's going to return a result. It's going to have no visible side effects. So we write some test where we assert based upon the result. Okay. I'm going to make, so we assert upon the result. Now, this is the standard case. You know, we expect some value back from it. There are absolutely objects where you have incoming messages. You would define it to be a query method because there's no other direct observable side effects other than to actually retrieve what's being returned by that method. But in fact, this asserting the result, whatever the result should be, only works in cases where it's very deterministic. Okay, so not very, it is deterministic. We know exactly what's going to come back so that we can assert what it should be. But let's say we actually have a class that's a random number generator. Now, these are pseudo-random number generators, so they seem random, but they're not really random, so they are deterministic. But each time we call, give me another random number, we're going to get another random number. It is not easy to just simply assert, oh, my next value should be this. If you were to be testing a random number generator and be testing its give me another value, you would actually have to come up with a much more complex test to be actually testing the nature of the values being returned to see whether or not they're actually behaving in what appears to be a random fashion. That's a much more complex form of testing, but I wanted to point that out, that it's not always as simple as it looks. Now, all the stuff that you're going to do in Rails, for the most part, you're not going to be writing random number generators and things like that. All the stuff that we're doing in 342, we're going to get some very simple results returned to us. We know what we should expect back. If we have an incoming call to us and we have a simple query, we'll just be returning some simple value. And yes, when we write the test for that, yeah, it'll be easy to just have an assert and result. All right. Now, we have a command method, and we're going to be testing people calling our command method. What we do is we write an assert we assert what the direct public. So public is visible, so we can see it from outside the class. Side effects are. And if it happens to also return a result, we would test the result as well. All right, I'm going to actually throw that pen down there and grab another one. We'll go through the pens until I have only good pens. All right. Internal to self. These are basically our private methods. So we've already covered this, which is do not test. We're not going to be testing any of these things because they have no visible side effects. We can't, from the outside of the class, tell anything about them, so we don't bother to test them. Okay? So this potentially saves you a lot of time in your testing, right? If you have a lot of these methods, you don't need to work around to try to test them, because you're going to end up testing them through the other methods which end up calling them. If these are broken, you'll discover that through the calls to the other methods that you're testing. Now, so I have this class object. I've tested basically this tests all of my class's public methods. This says don't test any of my private methods. So I test all my public methods. I test none of my private methods. But my class can have in it calls that it makes to other objects. Do I need to do anything about testing those? Well, the reality is sometimes yes. Okay. Now, if I make a query call, we do not test. Why is this? This is because this is received by the other class or other object, and it's tested, right? So it's up here. All of these query. So for the other class, we're busy testing it. We don't need to test our calls to other things that are already being thoroughly tested. And as well, the important thing is the idea of this is that there are no visible side effects. There are no visible changes to the state of the system. So when this object makes an outgoing call to another object that's a query method such that we don't expect any visible changes to the system, it's as though these things didn't really happen as far as we're concerned. They're just being called. So there's nothing needing to be tested about it because we're not changing the system. We're just querying and getting values from all over the place. We don't test our outgoing query calls. But if we do command, so we call a command on an external object, and so it has an incoming command. Now, it's not, oh, let's just worry about it. Let's just let it test itself. No, the problem is when we do one of these, this class that we're testing is going to affect change in the broader system because it's actually commanding some other part of the system to change itself. So a good example of this is what I had in the prior lecture, which was, oh, I'm testing a security system class, and it makes a call to the alarm class, the siren class, or something like that. So we absolutely want to make sure that that is called, because otherwise the alarm doesn't go off. Okay, so we need to make sure that that outgoing command has actually been made, so that we know that that appropriate change in the system, which is a very true side effect, an alarm should be ringing and making a loud noise, actually has happened. And so whenever we have one of these in place, this is when we use our mocks. So we use a mock to verify a call of this method. So if we as a class internally, we make outgoing commands to other objects, what we want to do is we want to use a mock to make sure that we made those commands. And the nice thing about using the mock is that then we break that dependency from the test perspective. We don't actually want to engage with the external objects. We want our tests to stay internal to ourselves. We want to be independent. We don't care about whether that other class actually works correctly. What it working correctly will be tested when it tests its command methods, but we do need to make sure that we made our calls to it, okay? Because if we don't do that, then we can have a big breakage. Us testing our queries to the other ones, that's not important. We don't need to test that because it's not going to change any effect of the state of the system. But these calls do change the state of the overall system, and we need to make sure that we've made them. But we use a mock then to isolate ourselves and stay independent. All right.